Oh, I didn't turn on the side. I should turn the side on for you, huh? You guys don't have to crank the neck.
Really?
Okay, number one's a really tough one. Hopefully you'll be able to get that one when we take it. Again, the exam's very similar to our quizzes. I don't try to trick you, I don't change it up, just change the numbers, right? So number one, I just want you to simplify that expression. So what do I have to do first? Correct. So negative 3 times 4x is negative 12x, and negative 3 times negative 2y is positive 6y. Can I combine any like terms? Nope, so we're done. Simple. Simple, simplify. Number two, can I subtract these two terms? No, why not? They don't have the same radicals, right? But can I simplify the radicals? Yes. So if I do my factor tree, 32 is 16 times 2. I circled the 16 because it's a perfect square. And 98 is 49 times 2, so I like to circle perfect squares when I see them. So what's the square root of 16? 4. What do I do with that 4 when I pull it out front? Multiply it by the 2. So that's 8 radical 2. That simplifies 2. What do I do with that 49? I pull out a 7. And again, there's a number out front, a 3 there. So I multiply the negative 3 times 7 and get negative 21. And then a 2 is left. Now are they like radicals? Yeah, so now I can subtract them. And 8 minus 21 would be negative 13. Radical 2. So you'll have one similar to that, where you'll have to simplify them first, and then you'll probably be able to add them or subtract them, depending on what type of problem it is. Questions? Okay, number 3 and 4 are just factoring problems. You're not trying to find what x equals. There's no equal sign. So what's the first thing we do when we factor? Greatest common factor, yes. Now, I gave you a list of steps for factoring. Okay, if you want to write those steps on your note card, that's fine. I don't care if you do that. But the first thing was on our list was look for a GCF, which is 3 in this problem. So I divide 3 into both of those, I get x squared minus 25. The second thing on our list is to look for a difference of squares. Do you see a difference of squares up there? Yeah, you should. A difference of squares is 2 perfect squares with a minus between. So we got to go another step. Our 3 is still part of the answer, and I make 2 sets of parentheses when I factor a difference of squares. And then I just take square roots. The square root of x squared would be x. I put that in the front of both sets of parentheses. And the square root of 25 is a 5. I put that in the back of both parentheses. Then I make 1 addition and 1 subtraction. The third thing on our list was the sum or difference of cubes. There was a certain way we did those. The fourth thing was a special trinomial. We call it a perfect square trinomial. The fifth one was regular trinomial, and the sixth one was grouping, which is what number 4 is, a grouping problem, because it has 4 terms. when you have a grouping problem, you still look for a GCF to start on all factoring problems, but there's no GCF for all four. So since there's four, we group the first two and last two. And we take out GCFs for the first two and for the first group and the second group. So the GCF for the first group is x squared, and the GCF for the second group is 2. When I divide 3x cubed by x squared, I get 3x. When I divide x squared by x squared, I get 1. So you have to put that number 1 there. All right, don't forget about that. 6x divided by 2 is 3x, and then 2 divided by 2 is 1 also. So we get 3x plus 1 in both binomials there after we took out the GCFs, and you want that to happen. You want the same thing to be in those two sets of parentheses. And that's one of our factors. So 3x plus 1 is one factor. And the other factor is those GCFs you pulled out, x squared plus 2. Okay, so 3 and 4 will be factoring problems. Any questions coming back to you, hopefully? We did a lot of factoring so far this semester. More the first 9 weeks than the second, probably. Number 5, we're multiplying two fractions. So when you have these types of fractions, you're supposed to factor. So more factoring to do before you multiply. Okay? Any of those numerators or denominators factorable? Yeah, the 5x plus 30. GCF's 5, right? So pull the 5 out. Divide, you get x plus 6. Do you see any factors that are the same that you could cancel now? Yeah, the x plus 6s, right? So the x plus 6s would cancel. That's all that cancels, okay? So you have to factor first, and I can only cancel factors. You can't just cancel terms. Like a lot of people want to say, well, I just cancel those x's. No. Binomials have to be exactly the same to cancel them. So our answer is x cubed for our numerator, and then the 5 and the x minus 7 for our denominator. It doesn't matter if you put the 5 in the front or back, or some people like to distribute the 5. You don't have to do that. This is fine. Okay. Number 6 is probably the hardest one of the first 10. It's not that hard, it just takes more time. Probably the one that takes the longest amount of time to do. Okay, in order to add two fractions, you need a common denominator. All right, so all you do is look at denominators to start. Don't worry about the numerators. So I have to get these two denominators to be the same thing before I can add them, or if it was subtraction, subtract them. Okay, so don't worry about trying to factor any numerators to start. Just factor any denominators that are possible to factor. And the second denominator, the one on the right, is factorable. There's no GCF, and it's not a difference of squares or some are difference of cubes. It's not a special trinomial. It's just a regular trinomial. The only way to get x squared would be x times x. Then you look at factors of negative 28. What times what equals negative 28. When you add the two, you get negative 3. It would be negative 7 and a positive 4, right? When I multiply those two, I get negative 28. When I add those two, I get the negative 3. Okay, so my common denominator is whatever shows up. You write it down. So x minus 7 showed up. So I write it down. X minus 7 showed again. I don't have to write it again. X plus 4 shows up, so I write it down. So that's my common denominator. So both fractions need that denominator before I can add that. All right, so if you look at the second fraction, both denominators are the same. The original and the common one are the same thing. So do I have to do anything to the first numerator? Or I guess the second numerator. I don't have to do anything to that one. It stays negative 12x minus 59. Again, don't try to factor numerators till after we add. Okay, if you look at the original denominator on the left, it was just the x minus 7. What I did to it to make it the common denominator is I multiplied by x plus 4. I got to do the same thing to the original numerator. I have to multiply it by x plus 4 also. Whatever you do to the original denominator, you have to do to the original numerator. So there's my two fractions. Before I can add this fraction to this one, I got to do that multiplication up top. Multiplication comes before addition, right? And Sally says there. So x squared for FOILing, outside, inside, or out, I'm sorry. First is x squared. Outside is 4x. Inside is 6x. And last is 24. Okay? Now I can add the two. And all I do is add the numerator. The denominator won't change. Once I figure out what my common denominator is, it stays my denominator. All I do is combine like terms for my numerator. So I got an x squared plus no other x squared. I got a 4x plus 6x is 10x plus a negative 12x is a negative 2x. And then I got a 24 plus a negative 59, which is a negative 35. Now I have it as one fraction. Okay? That's the goal. Now you want to make sure your fractions in lowest terms. Now is when you can factor the numerator if it's possible. Is it possible to factor that numerator? Are there factors of negative 35 that add up to negative 2? Yeah, negative 7 and positive 5. Do we see any common factors in the top and the bottom that I could cancel? Yeah, the x minus 7s, right? So those would go away. So my answer to this problem, finally, is x plus 5 over x plus 4. So that's the hardest one on the first 10. Because it takes some time. You got to do some factoring. You got to rewrite some fractions. You got to combine some like terms, and then factor again. But it's nothing you guys haven't done already. Again, none of this is new, right? We've done it already this year. You guys were pretty good at it too. Number 7, really easy problem, like number 1, just combining like terms. They're complex numbers because it's got that I in it, but you treat it just like if they were X's or Y's. You just got a 5 minus 11, and a negative 4 minus a negative 7, which is a positive 3, I. So all you got to do. Do not FOIL that one. The next one you got to FOIL because the next one is multiplication. Number 7 will be subtraction or addition. So just combine the like terms. Number 8, we have to FOIL the two complex numbers. You guys know how to FOIL. So this isn't that hard. But you got to remember this. I squared equals what? Nope. Negative 1, right? And what's the square root of negative 1? simplifying radicals, if there's a negative under there, that's when we started pulling that imaginary unit out, that I. That's something you might want to add to your note card. So doing FOIL first is 2 times 3. Outside is 2 times negative 9i. Inside is 7i times 3. And last is 7i times negative 9i, which is negative 63i squared. So there's that I squared popped up. Remember, that equals negative 1. So it's like negative 63 times negative 1, which makes it positive 63. Just get rid of that I squared. Combine like terms. 6 plus 63 and negative 18 plus 21. We get 69 plus 3i is our final answer after multiplying those two complex numbers. Number 9 is dividing two complex numbers. 4i divided by 2 plus 3i. So remember, I is the square root of negative 1, remember? So that's like having a square root in the denominator. Is that allowed? No, right? We have to get rid of the I in the bottom. It's okay to have i's in the top, radicals in the top. It's not okay to have i's or radicals in denominators at the bottom. So what you do is you take the conjugate, the complex conjugate of 2 plus 3i, which everybody knows is what? 2 minus 3i. And multiply the top and the bottom by that. All right, I usually put them in parentheses so you remember that you're distributing or FOILing. So when I distribute the 4i, I get 8i minus 12i squared. Here's that I squared again. So that's negative 12 times negative 1, which makes it positive 12. And then FOIL this. First, 2 times 2. Outside 2 times negative 3i. Inside 3i times 2, positive 6i. And last 3i times negative 3i is a negative 9i squared. There's that I squared again. So that negative 9 becomes positive 9. The middle ones, positive 6i and negative 6i, cancel. So our answer is 12. If I put it in the right order, 12 would go in the front and the 8i in the back. If you didn't do that, that's okay. And then 4 plus 9 would be 13. And then look, 4 goes into 12 and 8. Does 4 go into 9? Sorry, 4 go into 13? Doesn't go into 9. Okay, but if there's a number that goes into all three of those, you should divide that into them, to reduce it. So those three were complex number problems. 7 will be addition or subtraction, 8 will be multiplication, 9 will be division. Okay? Yeah, I'm just changing the numbers up. I'm not trying to trick you. Number 10 is an equation with fractions in them. And the way we solve these, you can solve them normally. Just take the 1/2 x over to the 2/3 x if you want. But you guys don't really like working with fractions. So what I showed you to do was find the common denominator and multiply everything by that common denominator, and that will eliminate your fractions, and then do the problem. Okay, so what is the common denominator? 6. So what we did then is we took the 6 and we multiplied it by all 4 terms. And when you multiply 6 times a fraction, it's just 6 times the numerator and then divided by the denominator. So 6 times 2 12 divided by 3 would be 4x. 6 times negative 5 is negative 30. 6 times 1/2 is 6 times 1, 6 divided by 2, which is 3. You guys know half of 6 is 3, right? And then 6 times negative 3 is negative 18. So now that's the same problem, just eliminated our fraction. Yes, sir?
6
Yeah, it's just, you can do that if you want. Just multiply the two denominators, that's your common denominator. Now you just do what you normally do. I'm going to bring the 3x on the right over to the left, so I'm going to subtract it. I'm also going to take the 30 over to the right by adding it. So I get x on the left and my constant on the right. So the 30's cancel and the 3x's cancel. And 4x minus 3x is 1x, that's what I want. And negative 18 plus 30 is 12. I'm done. Questions about the first 10? Okay, so as long as you're doing what you did today, you should be ready come Thursday. You know, work on tomorrow when we get here, I'll tell you to work on 11 to 20. And then when the bell rings, I'll start going over it. 11 to 20 with you. You got your little note card, you can write yourself little notes about the exam as you go. You can use that Thursday and Friday. Any questions? Good job.